So our next topic is closures. And it turns out that blocks, procs, lambdas, all these concepts we've talked about in Ruby so far are what computer scientists refer to as closures. Okay, so all of these constructs we've been talking about are closures. And what a closure is it's basically a function or a method that has a couple of different properties. The first property is that you can pass it around like an object. Okay, so a closure is a construct where we can take a function or a method and we can pass it around like an object and obviously call it at some point. So I can pass you a piece of code as an argument and then you can at will call that. So that's one of the properties of a closure. The second property is something we haven't really talked about yet, and it's kind of interesting when you first think about this concept. You're going to say, oh yeah, what does happen, right? So the second property is this: a closure remembers all of the values or variables, the values of the variables that were in scope when that function or when that code block was created. And so even when I pass that closure, that lambda or that proc or a block, to some other context and invoke it, the referential environment around that closure at the time of creation kind of go along with it. Okay, so the variables and their values that were in context when I create that closure, okay, get somehow associated with that closure object, and when I pass it around into a completely different context where technically that stuff seems like it would be out of scope, that context kind of lives with it and goes along. Okay, so the best way to understand this is with an example. So let's go ahead and look at an example in Ruby of both of these principles in the case of procs and lambdas, and especially that second one. So to demonstrate this, I'm going to create myself a Ruby class, and we'll have a constructor on here, and I'll set an attribute, an instance variable equal to what you send it, and I'll have a method, and I'll call this my val putter. And let's go with a lambda first. So I'm going to create a lambda here. So a very simple class that defines a single instance variable. So now I've got some context, right? I got an instance variable, and when you call this method val putter, it's going to create and return a lambda. Now note the interesting thing is when I create this lambda, it's created in a context, isn't it? And there is a variable called val, which happens to be an instance variable, in the object whose context I'm currently in. And so what I said, that second property, is that that context that lambda is created in, that referential environment, should kind of go along with that closure no matter where I send it to, even a different context. So let's create another method, and this one I don't have within a class, so as we discussed before, this one's going to basically end up as a private method on the parent class of all objects. And I'll just give it a name, some other context, and I'll pass it my lambda or my proc, and then I'll call that closure from within this other context. Okay, so everybody can see that that's a different object context, isn't it, than what the lambda was created in. So the next step will be to go ahead and create ourselves an object. And I'll give it the value 100. Then I'll grab that lambda by calling the putter method. And then I'm going to call that other context, passing the putter object that I created within the context of demo obj. So I'm going to go ahead and run this. Okay, and it prints out the value 100. And if we go back to the code, we've initialized demo object and set its instance variable val to 100. Then you've called this val putter method, which created a lambda object, and then we passed that lambda object to some completely different context, different object context. So that validates the first property, right? The fact that we can pass that lambda around satisfies the first property of a closure. And the fact that when the lambda was called and we say put @val indicates to us that that environment indeed did kind of ride along with that lambda, with that closure, and is available. So whenever I access those instance variables from the context that was created, those are actually retained and made available to that lambda. Does everybody see what's going on there? Okay, so those are the two properties of a closure. Now, procs are also. Go ahead, Stephen.
I was just wondering.
The only one thing I wanted to wrap up with on this example is procs are also closures and have the same behavior. And we can demonstrate that by simply coming down here and let's just comment out our lambda, and let's create a proc instead. So we'll say proc.new, and then we'll put the same block here. All right, and we get the same exact value. So procs have that exact same property. They're closures. The next question I think that is worth addressing, and Stephen kind of asked that question a few minutes ago, is how do you implement closures in programming languages? What are your strategies in order to do that? And there's, in general, a couple of different approaches that might make sense. One of the things we can do is that when you create a closure, so in Ruby vernacular that means a lambda or a proc, so at the time you create it, one option might be, let's do a snapshot of the lexical environment at the time and take that data, we'll just make a copy of it and we'll attach it to that lambda object in the implementation. So wherever that lambda goes, that data kind of goes along with it. Okay, so that's one viable option, and that's a way we could implement this. Now another option might be, and this is especially an attractive object if we're dealing with a garbage collected language such as Ruby, what we can do is keep a reference count to any objects that are in that lexical environment and basically retain them. Okay, so we're going to, as long as that lambda's around, we're going to retain and not garbage collect those objects that were referred to. Right? So for garbage collected, any type of instance variables, they're going to be objects themselves. As long as there's a closure around that was created in their context, it's going to have a link to them, if you will, and so the garbage collector is not going to collect them. And if we use this strategy, then the lexical environment that's getting shipped along with that closure is actually one and the same of the actual object instance variables when we created it. Okay, so they're actually the same. So in Ruby, what approach do you think Ruby takes out of those two? Well, let's take a look. So let's do one more example. And again, I'm going to have a class. I'm going to have a couple of methods. So I've got a class with a couple of methods. Val massager is creating a lambda and returning a lambda and it's created here in the context of an object, and it basically mutates an instance variable on the object instance. Then my second method, val putter, is essentially the same as the val putter before. It's going to print some output, and it's referencing the instance variable val as the output here. So if we create an instance, an object instance, and we give it a value, then we can grab the putter, and then we could call the second lambda to do some mutating on that object instance. And so now we'll just go into a little loop here. So I've created two lambdas. One lambda simply prints out data that was in the lexical environment of the object, or the lambda when it was created. The second one is going to change or mutate the lexical environment of the lambda when it was created. And I'm just going to call these a few times. And based on the output, we're going to be able to confirm what Chris has suggested. So let's run this. Oh, where is it? Oh, right here. Okay, so I started out with 2, and my massager lambda basically squared that instance variable every time I call it, and my output here, which is generated from the second lambda, puts out 4, 16, 256. So obviously what's happening here is that integer, that fixed num instance variable there is one and the same, isn't it? Every time I call it, it's basically updating the same data. So that indeed confirms that that second implementation option is used in Ruby. So what happens is the context is retained, and the closure, as it gets passed around and called, is going to operate on the original values that were there when it was created. You might be wondering, okay, so why are closures useful, this concept of closure in a programming language? We talked a little bit about why procs and lambdas are useful, and we talked about the don't repeat yourself principle, the dry principle. But this idea of closures, where the context that they were creating and the lexical environment that they were creating and gets preserved and shipped along with them, its usefulness really is somewhat dependent on the type of programming language or the model of the language processor that we're doing. And especially in pure functional programming languages, which is something we'll be talking about here in the near future, they tend to be stateless. Okay, so in pure functional languages, we don't necessarily have the assignment and the state concepts that we have in imperative languages. So closures, it turns out, in that programming model, is one way we use to preserve state. Okay, so functional languages use closures from a state perspective. Now, Ruby is an interesting language because it has some of these functionalities or these language features that you would think are more associated with functional languages than imperative. So it's sort of an interesting hybrid. Although it's it's definitely an imperative language, it has some of these features. And I would say that this support for closures in Ruby is what gives Ruby some of its conciseness and some of its compactness that you don't necessarily see in imperative languages that don't have some of those features. So imperative languages tend to be a little bit more verbose than functional languages, which are really in the the declarative versus imperative, right? And we saw that early in the semester. We said that imperative languages, kind of the programmer tells the computer how to do something. And when we move to declarative languages, the programmer kind of tells the computer what to do. So we tend to be working at a higher abstraction level. So these features in Ruby, I think, are what gives it some of its compactness and conciseness.